All right, so now that we've done that example, like I want to try to visualize this thing because this was just all a bunch of just algebra. So I built a Desmos module. I'll throw it into the homework question folder for this thing. So let me go to it. So here's the idea if you want to kind of play around with this thing. So the first thing is that we have a function, right? So f of x equals square root of x. That's obviously this black function right there. We could change it if we wanted to. But here's our function we're approximating. So as I change this value of a, we're going to start to see a line, a linear approximation. So the idea is that I'm trying to approximate f of 20 in this particular example. It doesn't have to be 20. What did we do before? We did 11, so let's do 11. All right, so there's f of 11. So f of 11, square root of 11 is about 3.31, blah, 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 blah. So if I change this value of a, notice what's going to happen, right? I can move it over. And as soon as I do it, I'm start to get a line. So this line right here is when a is equal to 1. So that's when I use this point right here when, well, a is 1, to approximate the value of f11. We can see this is a pretty crappy approximation because when I use 1, right, notice how the curvature of the line kind of shoots this tangent line way up. So this is saying that if I use 1 to approximate the square root of 11, well, my approximate value of the square root of 11 is going to be 6, which is pretty god-awful. So let's jump back to say 4, because that was a point that we used. So notice that as we went from a is 1 to a is 4, we're getting a much better approximation, right? We're obviously not exactly at it, but when we use 4 as our approximation, well, we're getting 3.75 like we found as our approximate value, right? So we're getting better. If I jump to 9, which was the next value that we used, notice that this is really, really, really close, right? So our approximate value of 3.3 repeating is really close to 3.3162. Obviously, there's still some gap between those two values. It's not exact, but this is really the idea of linearization. If we can get a good close value that we can easily take the square root of, right? Square root of 9 is an easy value to root. We can get a nice approximate value of what the function is going to be. If I jump to 16, well, notice what happens, right? I'm actually on the other side of the function now. I'm over here where 16 is. Actually, over here, if we're being honest with each other. Over here where 16 is, using that tangent line, well, there's my value, right? So we're kind of approaching it from the other direction. Still not a bad estimate, but not nearly as good as what we had when we used 9. And then the further away we get, right? When we go to 100, right? That was the value that we found. This is a really bad approximation because we're using some value that's really far away from 11. Using 100 to approximate the value of square root of 11 is just not a good choice here. It's very far away, right? That's kind of like the visualization. Now, because it's Desmos, I could do anything, right? I could use a is equal to 10, which would be a really good approximation. The only difference for like us in class is that we can't easily take the square root of 10, right? So using 9, using 16, using even 4 or 25 are better than using 10 just because you can't take the square root of 10 off the top of your head, most likely.